Guys and girls, it's Noah time! Hey, let's get crack-lacking! It's Noah time! Noah time!
Alright, so today I'm going to teach you how to graph polynomials using technology. So in other words, it's mandatory that you have a graphing calculator or else you can't do this. Can't be done. Graphing polynomials using that's the first thing I'm going to teach you. Plus, I'm going to go over a more wrap-up conclusion to polynomials. And really it's all the same concept, except I ask you a bit more theory questions. So I'm going to start off with a very, very simple thing. We're not done yet. So guys, this is like a sort of review from what you did before. I'm going to ask you this. Draw a graph. Before I give you a graph and you answer the following. Draw a graph with the following properties. Okay. With one turning point in quad 2 and has a y-intercept of -3. My question to you is, what shape is it going to be? So A, I want you to sketch it. B, tell me the degree of this. C, tell me the end behavior. That's all the information you're given. I want to see who can apply their knowledge from what you learned already.
What's A?
A is just sketch it.
How would you know
You won't. There's going to be more than one answer. That's the reason why. Guys, I'm going to pause it. And a lot of you are starting to get the hang of this. So anywho, let's talk about who matters now. So anywho, let's go. Right off the bat, I have a y-intercept of -3. I want you to put a dot at -3. -3. Done. I said there's one turning point in quadrant 2. So a turning point in quadrant 2 means I'm going to put a point anywhere in quadrant 2 you like. Turning point means that's where the graph turns direction. How can you have a graph that passes this line and have turning point here? You make that U. Back in the days. But now no one. But now he's a has-been. He's a one-time, one-hit wonder.
No, wait. I did something different.
What did you do?
I touched -3.
Oh no. That's called y-intercept. Means this is a y-axis. That's called your x-axis. Okay. Y-intercept means passes through the y-intercept line. Okay. So guys, gals, that's how you do this sort of thing. I'm gonna give you another one.
Is it degree 2 though?
Degree is 2, yes.
And then
And behavior is from where to where?
Do you guess where the vertex is?
Yep, because we don't know. See, you're working backwards from all the information I'm giving you now. Question. There will be a scenario, but not yet. I'll give you it later. For this one, it's just one answer. Yep. And Raj, question. The degree is 2 because what shape is this? Parabola. What is the highest power kind of
I don't know, man.
Come on, good David. Here we go. Y equals 2. You know it's parabola, right? So what's the highest power could a parabola have? 2. That's it. A parabola has the highest power, even though this should be a -2. But again, the key is this 2. That's how I know degree is 2. Next one. Try this one. You're going to draw it out and tell me all the good things about it. I have x-intercept, in a second, of 6, -4, and maybe -1. Turning point, turning points will be in quad 2 and what else can I make it into? 4. I want to know my degree. I want you to sketch it. Okay. So guys, gals, again, we're working backwards. See, this is theory because now it's not so straightforward. I'm asking you to work backwards now. What's the degree of this given this concept? 3 is correct. So if you're lost, again, the best way to do this is to draw a grid. Doot, doot. Now, notice I'm using x-intercept. Oh guys, it's kind of too loud, set it up. See, x-intercept, so I put a dot at -4, -1, and 6. I'm going to play the guessing game. So these are all my x-intercepts. I have the turning point in quadrant 2, so I'm going to put a dot. That's where my turning point lies. There. And I have one more in quadrant 4, somewhere, doesn't matter. Somehow I have to have a line that connects through all those points, because that's a policy. And the only way I can do this is if I go down, or sorry, up, down. Well, you want to think of like a connect dots, you could, but it's all about concepts. You should have an N. Tia, what's your degree? 3 is correct. Guys and gals, this is the sort of thing you have to do. So I want to go over some more things with you. Properties of a cubic function. I've taught you basics yesterday. Degree was 3, yep. Because this is a cubic function. Properties of a cubic function. A cubic function. Hi. Yep. The shape of the graph tells you what degree is. This is an N shape, so this we know is a cubic function, so it'll be third degree. Yep. A cubic function can have blank, blank, sorry, can have a maximum of blank x-intercepts. Says this, a cubic function can have a maximum of blank x-intercepts. If I look at my cubic function, what's the most you can have for a cubic function? 3. Because no matter what I draw, I can have a maximum. So these are basic facts. No, your degree is just based on how many turning points. Okay, that's cubic. I'm just saying that there are 3, maximum 3. I mentioned you can have maximum 3, but now I want you to draw a cubic function with only one x-intercept. I just showed you what 1 looks like with 3 x-intercepts. See? How would it work? And is it possible to draw 1 with only 1 x-intercept? I'm going to pause it. I walked around. Yep. I walked around and I saw a bunch of little neat answers. Some of you said, Mr. I'm going to do this. You start down here. You went up. That works perfectly fine. Okay? Because there's only 1 x-intercept here. And look, it still maintains the shape. That is the sort of thing that you'd be asked on. And again, there's many different variations. So the question is, yeah, you could. Because again, they're all cubic. You could. What you're saying is, can you start from here and you're going to go down like this? Yes, that works also. Okay. So guys, these are all examples. So therefore, now the question is, yep, is it possible to have 0 x-intercepts? Draw me one with 0 x-intercepts.
Cube?
For a cubic. I'm just asking, is it possible, first of all?
No, it's not possible.
It's not possible. No, doesn't matter. See, the minimum you can have really is 1. It's not possible to have 1 with 0 x-intercept. So, not possible. So again, these are all theory questions where you have to really understand your graph. My question to you now, you can work on this on your own. What is the max number of x-intercept a 4th degree graph, a 4th degree polynomial has? What is the max number of x-intercept for, I should say, for a 4th degree polynomial? Polynomial. That's A. B. What is the minimum number? So guys and gals, I want you to draw out both cases. One for the maximum and one for what the minimum should look like. I'm going to pause it and let you try this. So draw a sketch for maximum number x-intercepts and draw one for the minimum. I walked around and a lot of you say, Mr. No, that's easy. The maximum number I can have for a quartic function is, let's say if I look at this.
Can't you have 0?
1, 2, 3, 4. So this is max is 4. Correct.
Can't you have 0 with min?
Minimum. Question is, what is a minimum? People say 2, but Adria says, Mr. No, you can have 0. How can you have 0?
Because it could be upside down.
Draw me one with 0. Go for it. Oh, whoa, where's someone thinking? Is it? See, max is 4. But some of you say, Mr. No, I can have 1 with 0. 0 is actually correct. Because if I do like this, watch what happens. Doot, doot. Look, I'm never touching the x value. So therefore, this one, your minimum could be 0. This is called concept now. This is what you gotta think. So guys, this is the sort of thing I'll be asking you on your exams. Why can't I do 0 for the other one? How is it possible to have 0? Because if the line keeps on going up and keeps on going down, it's bound to cross the x-axis. No. Whoa, 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 whoa. No doesn't go sideways. Remember, no is a positive winner. No is not a sideways guy. Okay. So guys, gals, voila. Theory. Calculator time. Now, how do you graph this on your TI 83? Most high school students these days will use something called TI 83. When you're in college and university, there's a big push now. There's a new calculator coming out. It's called the TI Inspire. TI 84 was 5 years ago. Now every 5 years there's a new calculator coming in. This TI 83 is actually about 15 years old. Kid you not? 15. What you have right now is about 10 years old. That TI 83. It's been sitting around for 10 years already, and it still sells for $100. We bought it for $100. 10 years later, still sells for $100. The new TI Inspire is at about $15 more only, and it has color. You can do a lot. You can have a Wi-Fi function and everything.
What are you gonna do with Wi-Fi?
You can text your friend the answer. Oh, whoa, 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 please. Let's not take it that far. Oh, yeah. So, guys, grab your TI 83 out. I'm going to show you how to do this right now. I'm going to show you how to graph this on your TI 83. I'm going to get you to graph y equals to 2x cubed plus 10x squared minus 2x minus 10. they're going to say, use your graphing calculator, draw a rough sketch. The first thing people look at is, right off the bat, you should know what the shape, general shape looks like. Okay? It should look like an N. But the problem is, I didn't teach you how to find the x-intercept. I didn't teach you how to find the y-intercept. That's for pre-calc 12. They actually learned that in pre-calc 12. In foundations, what all you're going to do is know how to graph this in a TI-83. So grab your TI-83 out, and we're going to do this together. Okay? Here's my TI-83. Everyone has this. First thing you're going to do is you're going to clear everything out right away. You are going to hit something called Windows mode. What a Windows mode is, it tells you you're going to define what should your x max be on the right. Do you want to be 10 or 15 or 20? For now, I'm going to say my x max, I'm going to call it 15. I don't know what the answer should be. Everyone's going to be different. We're going to play the guessing game right now. 15. Under x scale really means how much should each x min? Oh, so x min means how far to the left do you want it. I'm going to call it negative 15 because I want to keep consistent. Negative 15. X scale, change it to 1. What x scale really means is how far apart should each line be. That's what x scale means. Y min. What is the lowest y value you want? For now, I'm going to call it, you can have negative 15 if you want. Make sure it's negative because we're talking about the lowest y value. I'm going to make it negative 20. Hi. We're changing the window mode right now. Windows. Because you got to change your scale.
Y scale would be 1, 2?
Yep. Y max I'm going to change to 20. So which means my highest I'm going to have is 20.
What was that x?
Y scale means how far should each line be apart be. Grid. Oh, don't worry about that. That's fine for now. No, we don't know. I'm playing the guessing game right now. Taryn, can you close the blinds? Thank you. So guys, girls, once you finish that, we are going to hit y equals. This is now where you enter your graphing information. You're going to clear all this out. Jason, question. Sorry? Okay, we're at Windows before, right? Now, you're going to hit y equals right now. Y equals is right here. Take a look at it. Top left corner, hit y equals. You're going to clear whatever they have up there. And what you're going to do is enter this the way you see it. You're going to hit 2. Now, there's an x. But the problem is you're going to look for the x key on your graph right here. Here's the x key right beside the alpha button. Hit x. X is right here. Take a look up here. Okay, now to power 3. But the thing is, your calculator doesn't have a cube button. So this is your exponent, this little hat right here. So you can hit exponent. 3. Okay, then you go plus. Then you do the next line. Yep, the whole thing. Question?
The whole thing on the first line?
Sorry, Jason. Sorry, what? This right here. That's x. Oh, this thing is the hat right here. This hat is the locator right here underneath the clear key. Can you guys see my little... Oh, now you see it? So now you're going to go... Not yet. We're going to do this together, this class. 10. Hit again, x. Now, if you want, we have a square button. You can hit square if you want, right here. Minus 2. Hit x. Minus 10. Everyone should be in that stage right now with the correct equation. Once you've done all that, hit the corner, top right corner. There's the graphing button. Hit graph. Okay, look at that. But the problem is, notice I played a guessing game of how high I should have, and when I go 20 max, it doesn't show the rest of it up there. Okay. Okay, I'm gonna come around and see. So guys, gals, I want you to go back to Windows right now. Change your Y max, because I want to see a bit more, because it's not showing in the top part. Nope, Y max, change it to 30. Clear it right now. Because see, notice when I graph it, it doesn't show, it's missing the top parts. So I want to go back to Windows, and I want to change it, so I want to see what the top looks like. I'm playing the guessing game because I don't even know the what. Huh? Yep, and hit graph again. If I change it to 30, see, look, it's starting to show me the whole piece right now. And if you have an error, I'm gonna come around, so I'm gonna pause it. Everyone should have that. So guys, I walked around, and a lot of you made some errors and asked me good questions. Say, Mr. Snow, how does the Windows change the graph? If I look at my Windows, notice X min, X max is how left. First of all, some of you were using this minus button as a negative sign. This is not your negative key. This is your negative key. I want you to play around with the Y min now. Change Y min to negative 40. See, because I'm saying, so what does that really do to the graph? And I want you to hit graph this time. See, when you go Y min equals to negative 40, look what happens. You see more of the graph, but the graph kind of shrinks. So that's what these min and max says. On your exam, I cannot tell you what the window is going to be. You play around with it until you get the right shape. Okay? So, you play the guessing game. Question, yep. Yep. Sorry. Yep. It's the same concept. Because what I'm going to ask you next is, we're going to do this next. Change your windows back. I want you to change it to negative 20 again. You could, up to you. Negative 20. What I'm going to be looking for on your exam is, here's what you can do. You have these little 4 cursor keys. I want you to take it, and the moment you do, you have this little target button that pops up. Move it to this first intercept, x-intercept. We're going to play the guessing game. Okay, there's a special function on your calculator how to calculate that, but now I'm going to show you how to play the guessing game first. This tells you where it crosses the x-intercept. So go guess where the first one's going to be. And it's going to be around negative 4.5, 4.8, around there. Yep. So we'll call it negative 4.8, just to make it for simplicity's sake. It doesn't matter, we're playing guessing game. Okay. So I know that's going to be, then we find the next one. Right here. Which is around negative 1, roughly. Sorry? Yeah, you could. This is it. So when you graph it on your own paper, you just show me these points. That's what we're looking for. There's a way to. Tomorrow I'm going to show you how to find it the more correct way. Yes.
Wouldn't the answer be different?
No, because it'll be off by point something only. But the shape will be the exact same thing. See, for this one, if I look at this again, it's be around 0.95, which we'll call it 1 to make it simplicity's sake. Now, some of you ask, Mr. Snow, what about these points down here? Take your cursor. It's kind of hard to see with this one. And you can actually go see where the lowest point on this loop is going to be. Okay? But it's kind of hard, so I'm going to give you another question. And you're going to graph this all on your own. So, hi, question. What's going on? Sorry?
2x cubed, 2x squared.
So you hit y equals to, and brings you to the screen. When you enter what you do, you can clear the whole thing out, and you're going to re-enter everything on your own. So guys, gals, I want you to graph. Sketch. You're going to sketch a few things for me. Number 1, you're going to sketch this using your calculator. Y equals to negative 2x cubed minus 5x plus 3. I'm going to ask you to do a few key things. Number 1, I want you to tell me my x-intercept, playing the guessing game. After this, I'll show you how to do it precisely. 2, the y-intercept. 3, I want you to tell me my domain and range. We're playing the guessing game first, and then after that, I'm going to show you a new function on how to find it more accurate and more precise. There is. No, there's a button that tells you your x-intercept, but not domain and range. So I'm going to pause it, and I walked around, and this is what you should have as your graph. So I'm going to draw this out right now. I went y equals to negative 2x cubed. Oh, I'm going to show you in a second. I'm going to show you how to get these numbers. This is my graph. So what I'm going to do is, hang on. I'm going to just draw the perfect copy of that graph right now. There's my graph. I just drew it perfectly. Okay. See, this graph, if I look at it, some of you say, Mr. Nobo, that doesn't look like an n. Guys, gals, news flash for you. A cubic function can have variations to it. In general, yes, the shape like an n, but this is what it looks like. Oh, what did I use for my windows? Windows, I use negative 15, 15, negative 20, and 30. No, there's no standard. Next thing. Some of you say, Mr. No, what's the x? Here's how you do this. I'm going to show you a few more functions on here. To find the x-intercept, yes, you can take your little cursor and you move around and you see where it crosses. But the problem with that is you're playing the guessing game. So there's some more functions on here. This is called the zoom function. Find the zoom key. Look at this right there. Look at there's a zoom button. Hit zoom. It's going to say, what do I want? I want zoom in. Hit enter. And now it's going to ask you, where do you want to zoom? So move the cursor to the spot where you want to zoom. I want to zoom in right about here because I want to see where it crosses the x. Oh, right here. Here's my cursor. I want to zoom in right about where it crosses the x. Hit enter. And look what happens. Oh, look at that. So now you can see a lot more clearly. So now what some of you did was you take your little cursor and you move it to this side. And it looks like around 0.55 x-intercept. X-intercept is about 0.53. That is actually the exact precise one. Who said that? Congratulations. But the problem with this is this. Look, I move it around and I say it's around 0.55. Some of you say, Mr. No, it's 0.56. There's a function on how to calculate it precisely. I want you to go hit second right now. So look up here, please. This is key. Second, see this trace button. Hit second, trace. What it does is it brings you to a screen called calculating screen. It asks you, what we're going to do is calculate the 0. The 0 means the x-intercept. That's what it means. Hit enter. Now it's going to say left bound. Left bound means choose a point to the left of the x-intercept. So your cursor should be flashing to left already. Hit enter. Move it. Now it's going to say right bound. Look where your cursor is. Move it to the right. Say move it to the right of the x-intercept. Say look, it's to the right now. Okay, I was left bound. If your cursor is to the left of the x-intercept, hit enter. Okay. Okay. So hit enter. I'll do this again. So let me show you again. You go second, calculate. You go 0. It's going to say left bound. Wherever your cursor is, I want you to move it to the left of the x-intercept. See? That's to left. Anywhere to left is fine. Okay, we'll find out in a second. Yep. Anywhere to left, see? Hit enter. You got to hit enter. Anywhere to the left of the x-axis. Yes, of the x-intercept. Why do you enter? Because it records it in. Now it's going to say right bound. So move it to the right of the x-intercept. There's to the right. I want you to hit enter again. Because you get entered in. Then now it says guess. What the calculator is asking is, should I take a guess? Hit enter again. And if it takes a guess, the guess is exactly at 0.537. That is the most precise way you can get the x-intercept. No, it has to be 0.53.
How do you do that?
Okay. So guys, gals, or sorry, 0.54. I'm going to come around, take a look, and you're going to show me how you entered it wrong. So I'm going to walk around. I'm going to pause it. And so this wraps up your graphing bit. Page. 383. Numero 3. You're going to get some practice graphing. And then I'm going to jump a bit, and we're going to do page. 388. Sorry, not 388. My apologies. Nope. 393. Oh, by the way, we're halfway through the chapter. Heads up. Hi, that's it. Hi. That's it. The last few, I spent a lot of time probability because those are a bit more challenging. This, guys, what were you doing? Let's go back. Numero. 4. Sorry, number 3, 4, 6. Hi. Tell it to me and tell me why I should care and all that good stuff. That's it, guys. You will have a huge quiz tomorrow. Half of your time tomorrow will be spent on quizzes. I repeat, it'll be long, it'll be tough. Hi. And that's our lesson for today.